Greetings everyone. So today we are going to present about centrifugation. Let me explain first the basic concept of centrifugation. Centrifugation is a process that used to separate components of a mixture based on their density or particle size. This is done by spinning the mixture at high speed in a device called a centrifuge by creating centrifugal force. So here how it works. First, the sample is placed into a special vial or rotor inside the centrifuge. When the rotor spins rapidly, the centrifugal force will push the denser particle away from the center of rotation, causing them to settle down at the bottom and form, we name it as a pellet. The remaining liquid above, we call it as a supernatant. So several factors affect the separation includes density difference, particle size, speed of rotation, and also time. This will determine how efficiently the components are separated.
Now let's see about the type of centrifuges. So there are basically 9 types of centrifuges and I will be presenting 5 types first. So firstly, let's see about the benchtop centrifuges. These centrifuges are very compact and versatile designs for centrifugation, and it features an ergonomic design with safety measures and advanced interfaces. So these centrifuges can accommodate various rotors, and it offers temperature control options, built-in refrigeration, and specialized applications. Next, we would see the gas centrifuges. So the gas centrifuges is specialized for isotope separation in gases, and it uses the centrifugal force for mass-based separation. So let's see. So the modern models operate in cascades for efficient separation for the gas samples, and it also has enclosed in, and its anti-centrifuges are enclosed in casings for friction reduction. These type of centrifuges can use countercurrent flows for enhanced separation of gas samples, which is the isotope separation in gas. Next, we would see the hematocrit centrifuge. So this centrifuge measures volume percentage of red blood cells in a blood sample, and it spins the blood samples at high speeds, and it separates the component based on density, where the red blood cells will have the highest density, then followed by the white blood cells and the platelets. And these type of centrifuges helps to calculate red blood cells proportions for diagnosing conditions such as anemia, sickle cell anemia, type of that. Next, we would see the microcentrifuges. So these are compact high-speed device for very small sample volumes, and it's very ideal for hematology, microbiology, biochemistry, and molecular biology. These microcentrifuges separate solid and liquid with different densities, and its characteristics are high-speed refrigerated variants available for specialized tasks, like for hematology, microbiology, and biochemistry. They have a specialized tasks respectively. Next, we would see the refrigerated centrifuges. These are mainly for biological or microbiological research. So these are high-speed cooling machines to maintain sample integrity. So to maintain the pureness of a sample, we would use the refrigerated centrifuges. These type of centrifuges can reach speeds exceeding 12,000 RPM, and it prevents evaporation or contamination of samples.
First, let's talk about the low-speed centrifuge. This one spins at around 4,000 to 5,000 RPM, and it's usually used in labs for basic tasks like separating cell. It doesn't need more temperature control and works at room temperature. The rotor used include swinging bucket and fixed angle types. So the next one, we have a high-speed centrifuge. This one, it goes faster, between 50,000 to 30,000 RPM, and it's used for smaller particles like mitochondria. It has temperature and speed control and use 3 rotor type, which is fixed angle, swinging bucket, and vertical. The third one, we have the ultra centrifuge, which is the most powerful one, and it can reach speed from 60,000 to 150,000 RPM. It's used for separate very tiny things like protein and viruses. It's more advanced and can be run in group or continuously. So the last one, we have a continuous flow centrifuge. This one is special because it can handle large volume of sample without stopping. You don't need to keep reloading it, which is make it great for industrial or large-scale use.
Hi guys, let's move to the types of centrifugation techniques. Actually, it divides into two, differential centrifugation and also density gradient centrifugation. So, what is differential centrifugation? It is a technique that used to separate cellular component based on the size and the density by spinning with different speed. Okay, as I said, it based on the size. So it has a large particle, medium particle, and a small particle. So different size have different speed. So as we can see, large particle using a low speed spin, and while for the medium particle, using a medium speed spin. Lastly, for the small particle, it use high speed spin or ultra centrifugations, which means it has a higher speed spin. Okay, then we move to the density gradient centrifugations. It is a technique that used to separate particle by spinning a medium with a density gradient, which it reach a position where the density of the particle equal to the surrounding. It is divided into two, which is red zonal centrifugation and also isopyne. Okay. So to easily understand, for both, we can do a comparison or differentiate between both types of density gradient. To easily understand difference between red zonal and isopynic is the nature gradient, which is the red zonal has a shallow gradient because red zonal is based on the size and shape. So, low particle or small particle has low density, large particle has large density. So the low particle or small particle will move to the top of the gradient, and the large particle or large density will move to the bottom of the gradient. Meanwhile, for the isopynic is based on the buoyant density, which is the particle has its density, which mean that it doesn't seem with the red zonal, which the particle will move according to their density. I give you some example is if there is a two particle, okay, small particle may have low density and it also have medium density. So the small particle will move to the top and maybe it will move to the medium gradient. For the large particle, it might have a medium density and also it might have a large density. So it also might move to the medium gradients and also it might move to the bottom gradients. So that's all from me.
The next part is parameters in centrifugation. There are several parameters in centrifugation that need to be considered in order for we to get a good result. The first one is rotational speed, which measured in revolutions per minute. It determines how fast the centrifuge rotor spins. Higher speeds will generate greater centrifugal force, which is essential for separating materials based on density. The next one is relative centrifugal force, or also known as G-force. RCF represents force applied to the sample relative to Earth gravity. RCF is a more meaningful parameter rather than rotational speed because it accounts for rotor size and sample distance. The next one is time duration. So the longer the test, the more you find the separation. And the last one is sample volume and tube size. Sample volume and centrifuge tube size must be compatible with the rotor's capacity. This is because overfilling or underfilling tubes can lead to inefficient separation.
Okay, next I'll explain about how to calculate the parameter. So firstly is calculating the RCF. RCF is a critical parameter that determines the force applied to the sample. It depends on the rotational speed, RPM, and the radius of the centrifuge rotor. So the formula given is RCF equals to 1.118 times 10 power of negative 5 times R times RPM power of 2. So RCF is the relative centrifugal force, R is the rotor radius in cm, RPM is the rotational speed in revolutions per minute. So first step to calculate the RCF is by measuring the rotor's radius R. So next is determine the desired RPM, and lastly plug the values into the formula to calculate the RCF. So for example, if the rotor radius is 10 cm and the centrifuge operates at 3000 rpm, the RCF can be determined as follows. RCF equals to 1.118 times 10 power of negative 5 times 10 times 3000 power of 2, so equals to 1006.2 gram. Next is calculating RPM from RCF. So if you know the required RCF and rotor's radius, you can calculate the necessary RPM. So the formula given is RPM equals to square root RCF over 1.118 times 10 power of negative 5 times R. So step first is determine the required RCF, then measure the rotor's radius, then plug the values into the formula to calculate RPM. For example, if the required RCF is 2000 gram and the rotor's radius is 8 cm, the RPM can be determined as follows. RPM equals to square root 2000 over 1.118 times 10 power of negative 5 times 8. So the answer is moderately equals to 4482. Thus, the centrifuge needs to run at approximately 4482 RPM to achieve the desired 2000 gram force.
Okay, so how is centrifugation applied in organic structure determination? Firstly, centrifuges actually do not directly contribute to the determination of organic structure, but instead it is used for preparing the samples for structural analysis techniques like spectroscopy or chromatography. So how does it help in sample preparation? Firstly, it helps isolate specific components, separating cells, organelles, or specific macromolecules from a complex mixture. Secondly, it helps purify samples, which removes unwanted materials or impurities from a sample before analysis. And lastly, it helps concentrate samples, which means increasing the concentration of a target molecule or substance for easier analysis.
Let's move on to the next part, advantages and limitation of the centrifugation method. First, operation centrifuges operate in a fully enclosed system, which helps maintain a clean and organized workspace. This not only improves hygiene, but also makes the setup look professional and less messy. However, high-speed spinning can produce noise and vibrations, which might be an issue in sensitive environments. Next, cost efficiency in terms of output. Centrifuges offer a great cost to capacity ratio. Over time, they prove to be economical for many industries, but it is important to note that the upfront cost for purchasing and installing a centrifuge can be quite high, especially for advanced models. Third, automation. Most modern centrifuges support automation and continuous operation. This means they can run for long hours with minimal supervision, saving time and labor. Still, if a technical problem occurs, it usually requires skilled technicians to carry out maintenance or repairs. Performance centrifuges are highly effective in separating solid from liquids and are used widely in biology, chemistry, and waste management. Their performance is reliable for most applications, though they can struggle with very light or fine particles that are difficult to separate completely. Fifth, easy of use. One of the reasons centrifuges are so common is that they are generally easy to operate and simple to set up. However, like any equipment, they do require regular maintenance to keep everything running smoothly and to avoid downtime. Last but not least, odor control. During sludge treatment, centrifuges can help reduce unpleasant smells by efficiently separating water from waste. This makes the process more bearable and sanitary. On the downside, they often require a significant amount of polymers, which can increase cost and waste. That's all from us. Thank you.